You'll have more time to practice. Okay, number 7. There is a rule that says you cannot leave a root in the denominator. Just like there was a rule that says you're not done with exponents until you don't have any negative exponents anymore. Okay? Why? Why do we do it? Just because some old guy back in the day said this is the way we do it. Alright? So, we're not going to leave any root signs in the denominator. So, this has a root sign in the denominator. The easiest way, or not necessarily easiest, but a very consistent way, right? Instead of showing you 5 different ways of doing it, which sometimes I feel is to your benefit, and sometimes I feel is not to your benefit, so I'm not going to show you a bunch of different ways. What you can do is, if you don't want to have a root sign in the denominator anymore, a radical sign, you multiply by what's in the, you multiply by that same root. So what I'm going to do is I'm going to multiply this by the square root of 80. This is one approach. This is not the only way to do it, but this will always get you to where you need to be. Now let's talk about this for just a second. This is the square root of 80 times the square root of 80. What is the square root of 80 times the square root of 80? Making it too hard. In other words, what is the square root of 80 times 80? You're making it too hard. Mary? Yes, it would be 80. How many are there? There's a group of 2. See, I said you were making it too hard. The square root of 80 times the square root of 80 is just going to be 80. Oh, look, I don't have a radical sign in the denominator anymore. Hooray, that's what I was trying to go for. However, this represents a certain amount. So if I gave you this amount of pizza, let's say, this needs to represent the exact same amount. I'm changing how the numbers look, right? I'm going from the square root into just 80. I'm changing how it looks, but it can't change how much it represents. Just like if I gave you half of a pizza, if I gave you this much of a pizza, that's the same amount. If I gave you this much of a pizza, that's the same amount. I changed how it all looks, but it represents the same amount. So let me ask you, if I was going from 1/2 into something over 32, how does 2 change into 32? What did I do? I multiplied it by 16. Oh, if I multiply this by 16, what else do I need to multiply? The numerator. 1/2 is the same amount as 16 over 32. The numbers look different. What they represent is the same. Why am I allowed to do that? What is this number really? 1. So we have to take this amount. We can change how it looks, but we can't change what it represents. So if I'm going to multiply the denominator by the square root of 80, I have to multiply the numerator by the square root of 80. Because what is the square root of 80 divided by the square root of 80? What is it really? 1. The square root of 80 divided by the square root of 80 is 1. I'm really multiplying by 1. You're allowed to multiply by 1. It does not change how much the quantity represents. Okay, so over here I'm going to have 5 times the square root of 5 times 80. Well, you can either say 5 times 80 is 400, and then know that 400 is a perfect square? How many of you instantly thought, oh yeah, 400, perfect square? Yeah, nobody. Or, instead of making the number bigger, because if you make the number bigger, then what do you have to turn around and do? Make it smaller. So I'm going to say 80 is 8 times 10. I know that the 8 is 2 times 2 times 2. And I know that 10 is 2 times 5. I really hate when I run out of space. So I took the 5 and I brought it down, and then I broke down the 80 into 2 times 2 times 2 times 2 times 5. So, oh, no, I'm not going to do it that way. So I have 5 times, here is a group of 5s. Here's one group of 2s. Here's another group of 2s. And don't forget, all of that was still over 80. Five times 5 is 25, times 2 is 50, times 2 is 100. So this is the same as 100 over 80. Both of those can be simplified by dividing by 10. So I'll just cross off a 0 for both of them. That divides by 10 on both of them. And then what number can still go into 10 and 2? 10 and 8, sorry. I said the answer. So I can divide this by 2 and I can divide this by 2. So 5/4. So the final answer to all of that nonsense was 5/4. Okay. What is in the square root sign in the denominator? What's in the square root sign? A 5, right? So what do I need to multiply to get rid of the square root of 5? Multiply by the square root of 5. So I'm going to multiply by the square root of 5. And I'm really multiplying by the quantity 1, right? All right, let's ignore this for a second. What's the square root of 5 times the square root of 5? 5. So I'm going to have 5 times 5 in the denominator. And in the numerator, isn't this a perfect square? What's the square root of 4? 2. So this will be 2 square root of 5. Oh, you're right. I don't know why we didn't do number 8. We'll go back and do that right now.
Why did you do like the like you have like 5 square root, like it was like I can't really explain it to you guys.
Why did I multiply by this?
No, the numerator part. Like why
Because what is the square root of 5 divided by the square root of 5?
divided?
Right, I really multiplied by 1. Just like this, when I was saying that 1/2 is the same as 16 over 32, how did the 2 turn into the 32? I multiplied by 16. But 1 over 32 is not the same as 1 over 2, right? So I had to multiply the numerator also, because I'm multiplying by a factor of 1. Okay. Is anything here a perfect square? I'm going to go back and do number 8. Is anything a perfect square? What? 9, right? What is the square root of 9?
3.
Okay, so instead of multiplying by the square root of 9, the square root of 9 is 3. So the denominator becomes 5 times 3. And look, I don't have a radical sign anymore. And is there anything I can further simplify? 6. What? Not the 6. The 5. I can simplify the 5s. So then that gives me the square root of 6 over 3. You cannot break this down further. Because what did I say? We don't have our games or our phones out right now. Thank you. This is really, I can rewrite this as 6 to the 1/2 over 3. Do they have the same base? Do they have the same base? No, that's why I am done. I'm done right here. Okay, let's look at number 9. What's causing the problem in number 9? What's causing the problem in number 9? The denominator, right? Because there's a square root down there. We can't have a square root. So what am I going to multiply by? The square root of 3. If I multiply the bottom, I have to multiply the top. So what is the square root of 3 times the square root of 3? 3. And what is 3 times 5? 15. And what's the numerator going to be? The square root of 15. And that's done. That one made sense? Okay. So, the problem down here, because we already did number 10, the problem down here is this is a square root. So what am I going to multiply by? By itself. That's always the answer. Multiply by itself. What is the square root of 3n times the square root of 3n? 3n. Perfect. The square root of 4 times the square root of 5n times the square root of 3n is going to be 5n times 3n underneath the radical sign. And then I have a group of n, so I can remove 1, so that's going to give me 4n times the square root of 15 over 3n. Is there anything else I can simplify? Is there anything else I can simplify? The n's, exactly. Okay. All right. This is under the square root sign. What do I multiply by? Right. Multiply by itself. That's the easy. It's not the only way. It's just a very consistent way. And if I multiply the denominator, I have to multiply the numerator.
That's what I just now realized.
Oh.
Because I realized why you did that.
Good. Awesome. So what is the square root of 3x y to the 4th times the square root of 3x y to the 4th? 3x y to the 4th. And then in the numerator, I'm going to have the square root of 2 times 3 times x times y to the 4th times y to the 4th. And I'm looking for groups of what? 2. Oh, here's a group of 2. Here's a group of 2. So that means I'm going to remove 1 x to the outside. I'm going to remove 1 y to the 4th to the outside. I still have the 2 and the 3 on the inside, so that's going to be 6 over 3x y to the 4th. Is there anything I can simplify? The x and the y to the 4th. And then that one's done. So your practice is 20 problems on this, and we will practice more tomorrow.